Okay, so we chose 15-degree target angle for the XP series because it gives us a more homogeneous dose. So across the beam you get a more constant dose profile. And secondly, it gives us a bigger angle, a bigger usable angle across the beam. So with a 15-degree target we can use more of the flat panel compared to an 11-degree target for the same focal spot distance to target distance. And it also allows us to have a more consistent focal spot, or less distortion of the focal spot across the beam. So with a 15-degree target you get less distortion of the focal spot in the corners of the flat panel compared to an 11-degree target. So we have two focal spots that are thermally separated, which means we have two emitters focusing on two separate parts of the target. And this means that we have a longer tube lifetime, so the user can switch from one focal spot to the second focal spot when the first focal spot is used. And this has good advantages for the users who are using inline applications, because they can get to the end of one focal spot lifetime and switch straight away to the second focal spot and continue using the tube in their application without any break in production. And then they can plan maintenance for the continuing part of the life cycle. So the story was, I designed the two focal spots to land on the target, but a long way apart from one another. And when my boss saw them, he said, "Wow, are you sure they're landing on the target?" Because the target's quite a small area. We wanted to make sure that both focal spots were thermally separated, but not actually missing the target. But actually they were okay, they were on the target. And he was quite happy about that too, and so am I.